So here's an example of a problem called related rates problem. A water tank has the shape of an inverted cone with base radius of 2 meters and height of 4 meters. If the water is being pumped into the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. So here is an illustration of an inverted cone. This is a tank and water is going into this tank. The radius of the circular base of this cone is 2 meters and the height of this tank is 4 meters. As water goes inside this tank, the water is also going to take a form of a cone. The height, of course, is a variable. It rises as water goes into the tank, as well as the surface of the water is in a form of a circle. And as the water rises, the circle is also getting bigger, and therefore the radius is also a variable. We are going to represent the radius with r, and we are going to represent the height of the water with h. This problem is asking for the rate at which the water level is rising, and therefore we are going to look for the rate of h, or we are going to find dh dt. Also, it mentioned that the rate at which the water is pumped into the tank is 2 cubic meters per minute. Therefore, the derivative of the volume or the rate of the volume is positive 2. We are going to write that as dv dt. It also mentioned that at a specific instance in time, the height of the water is 3 meters. Therefore, h is equal to 3. We are interested at that moment when the h is 3. When the height is 3, there is also a corresponding value for r, the radius of the surface of the water, but we don't know that yet, so we are just going to write that as r. It also mentioned, of course, that the height of the tank is 4 meters and the radius of the tank is 2 meters. So we are going to write capital H as the height of the tank and capital R or uppercase R as the radius of the tank. We are going to use the formula for volume of the cone. This volume, of course, represents the volume of the water, and the water is in the form of a cone. We are going to find dH dt, so therefore we are going to find the derivative with respect to time. The derivative of v with respect to time is dv dt. We are also going to get, therefore, the derivative of the right side of this equation. And as you can see, there are two variables involved, r and h, and they are being multiplied together. Therefore, we will be using the product rule. So let's go ahead, find the derivative of the left side and the right side of this equation. First, the derivative of v is dv dt, and we are going to use the rule for the product rule. So I'm going to copy 1/3 pi r squared h. We are going to multiply this by dh dt. Plus, we are now going to get the derivative of the first part of this function. But first, I'm going to copy h, multiply this by the derivative of 1/3 pi r squared, and then we are going to multiply that by dr dt. Now let's simplify this. Now let's take a look and identify what we have and what we are going to find also. This problem is asking for dH dt, so let's indicate that with this red circle. That's our ultimate problem. To be able to find dH dt, we must have the rest of the variables or the quantities involved in this equation. We have obviously dv dt, we have a value for that, which is 2. However, we don't have a specific value for r, and we have the value for h, it's 3. We also don't have the value for dr dt. So we will not be able to continue in finding dH dt because we now have two missing values, r and dr dt. So let's take a pause. We will come back to this. We will find first r and dr dt. Now, if you are going to look at our cone, and if we are going to drop a horizontal, or rather a vertical line from the center of the circular base of the tank straight to the tip of the tank, we will have a triangle on the right side that look like this, where the top side of the triangle is 2 and the height of the triangle is 4. In the same way, if we are going to look at a triangle formed by the water, and the height of or rather the base, the radius of this triangle is r, and the height of these is h. These two triangles are similar, and so therefore their sides are proportional. As you can see, R corresponds to 2 and H corresponds to 4. So therefore we can write R over 2 equals to H over 4. Now we are going to solve for R, so we will multiply left side and right side of this equation by 2, and we are going to simplify. So R is equal to 2H over 4, or R is equal to 1/2 H. We can make use of this equation and we can get the derivative of the left side and the right side with respect to time. So therefore we can say dr dt is equal to 1/2 dh dt. Furthermore, we can also substitute 3 into h in order to get the value for r. So therefore we have r equal to 3 over 2. So we now have the value for r, 3 over 2, and we now have the value for, well, not the value, but we have now something to substitute into the rdt in terms of dh dt. So we go back to our equation again one more time. dv dt is 2, r is 3 over 2, h is equal to 3, and dr is going to be substituted by, or rather dr dt is substituted by 1/2 dh dt. So this is how it will look like. Alright, so we are now going to simplify. We are going to square 3 over 2. That will give us 9 over 4. We will also multiply 2/3 times 3/2, and we will multiply 3 times 1/2 and simplify. Now we are going to factor out the HDT, and now we are going to add the two fractions and pi together inside the parentheses. Of course, we have to make the denominators the same first. We are now going to multiply left side and right side by 4 and divide also left side and right side by 9h. So ultimately we have dh dt is equal to 8 over 9 pi. So this is the rate of the height when the height is exactly 3. And the unit for this, of course, is meters per minute. So this is the rate at which the water level is rising when the height is exactly 3 meters. Now, as you can see, it's quite tedious. There's so many steps involved, but there's also another way to solve this problem, which for me is a lot simpler and a lot shorter. Let's take a look at that particular way of solving this problem. Here we still have the value for R to be 1/2 H, and let's have again the volume formula. Now, instead of getting the derivative for R as well as the derivative of 1/2 H, we are just going to directly substitute this into the formula for volume. So we are going to substitute R squared, or R, by 1/2 H, and it will look like this. Alright, so we are now going to simplify. So 1/2 H squared will become 1/4 H squared. Now we are going to multiply 1/3 times 1/4 and then H squared times H. So we now have a very simple formula for volume that involves only H. So you have V equal to 1 over 12 pi H cubed. We are now going to get the derivative with respect to time. So dv dt is equal to 3 over 12 times pi H squared times dh dt. Alright, so now we can now substitute dv dt with 2, and then we know the value for H is 3. So upon simplifying, we are going to get still 2 is equal to 9 over 4 pi dh dt, and therefore it will give us the same answer for dh dt as 8 over 9 pi. The unit is meters per minute. So as you can see, it gives us the same answer, and this second way of solving is a lot simpler and shorter. So the final answer to the problem is, of course, 9 over, or rather 8 over 9 pi meters per minute. Thank you.